Here we go. We're on to question 4. It is a circle question. So you can see I've done a little bit of working out here for us already. Okay. We have two circles. C1, x squared plus y squared minus 6x minus 4y plus 12 equals naught. C2 is x squared plus y squared plus 10x plus 4y plus 20 equals naught. They are two circles. We need to find the coordinates of their centers, P and Q, and the lengths of their radii, R1 and R2, respectively. Now, if you, as many people will kind of think about this equation as x squared plus y squared plus 2gx plus 2fy plus c equals naught. We know our center is minus c minus g minus f. So if 2g is minus 6, well then minus g is equal to 3. If 2f is equal to minus 4, then minus f is equal to 2. C is equal to 12. So g squared plus f squared minus c will give you the square root of the square root of g squared plus f squared minus c gives you the radius. Turns out to be root 1, which is 1. Okay. Now the other way of doing it is completing the square method. And some people will be familiar with this and will understand it easily, and others will be looking and saying, well, what are they doing here? So very briefly, what I can say is if let me just change pen color here. So if I say x squared and minus 6x, well, then I can say I can do a completing the square where I have x minus 3 to be squared. And that would give you, if you square that out, it give you x squared and it give you a minus 6x. But it would also give you a plus 9. So that plus 9 wasn't there originally, so you'd also have to have a minus 9 to balance that out. But that minus 9 then, if you add it to both sides, or you bring it across the equal sign, would become a plus 9 over there. So that's where that plus 9 comes from. Okay. Equally, if we did it for the y's, and we look at the y minus 2 to be squared, well, what's that all about? Well, if we have a y squared and we have a minus 4y, so if we have a y squared and a minus 4y, and we complete the square there, we get y minus 2 to be squared. But that y minus 2 to be squared, well, that would give you y squared, and it give you a minus 4y, that's fine. But it would also give you a plus 4. But to keep everything in balance, you would also have to subtract the 4. Now bring that over to the other side, and it becomes a plus 4 over there. So that's where those numbers come from, the 9 and the 4 on the right-hand side. Where does the minus 12 come from? Well, that comes from, the plus 12 on the left-hand side. You're subtracting 12 from both sides. Then you end up with x minus 3 to be squared plus y minus 2 to be squared equals 1. The center of that, using our form x minus h to be squared plus y minus k to be squared equals r squared. That will give you your center of 3, 2, and your radius of 1. Okay, same trick then for the next one. If we do the center using the minus g minus f, 2g is equal to 10, so minus g is 5. 2f is equal to 4, so minus f is equal to minus 2. C is equal to 20. If I do my radius formula, square root of g squared plus f squared minus c, I end up with a root 9, which is equal to 3 as my radius. And if I do it completing the square method, I end up with x squared, x plus 5 to be squared plus y plus 2 to be squared equals 9. The center is minus 5 minus 2, and the radius is 3. Okay, so exactly the same either way. So 10 marks for that. Quite a bit of work in it, but straightforward work you're familiar with anyway. Okay. Verify that these two lines are tangents to the circle C1. Okay, y minus 1 equals 0, and 4x minus 3y minus 1 equals 0. Okay, so there are different ways to do this, right? But one way to do it is get the perpendicular distance from the center of the circle to the line itself, and that should be equal to the radius. So if you get the perpendicular distance from the center point 3, 2 to the line, and in our case here, that we're talking about the line L, So if we're talking about the line L being of AX plus BY plus C equals naught, well, in that case, your A is going to be equal to 0, your B is going to be 1, and your C is going to be equal to -1. So, because just to clarify that, there'll be AX plus BY plus C equals 0. A is equal to 0 because there's no X. B is equal to 1 because it's 1Y. And C is equal to -1. So you fill all that in here, and you're hoping to get an answer of 1, which in fact you do. Let's try the same here for the second one. Our second equation, M. In this case, A will be 4, B will be -3, and C will be -1. You fill it all into your perpendicular distance formula. You get 5 over 5, which is equal to 1. So both of these equations are tangents to the circle. You can, of course, do a simultaneous equation method as well, and you will find just one point of contact doing that. But as we say here, L and M are tangents to C1 as the distance from the center of C1 to the line is equal to the radius of the circle. Okay, so 10 marks for that. It then says the point M is the intersection of these two lines. Okay, the intersection of the two lines that we've just mentioned. Given that M is on the line P to Q, where P is the center of C1 and Q is the center of P2, show that the ratio of P to M is the ratio PM, so that distance, is to MQ is the same as the ratio R1 is to R2, so the ratio of the radii. So that is a question, some people have to read that a few times. And again, the old phrase, if you don't know what to do what you know. You start off, you say, okay, find the point of intersection. Okay. We know we have our two circles. P is as a circle, center 3, 2, radius 1. Q has a center -5, 2, radius 3. If we start off with L and we say, well, we have the line y equals 1. Okay, that's a horizontal line. And we can see there on the diagram, it is a tangent, as we said. M2, or M, I should say, is line 2. 4x minus 3y minus 1 equals 0. We can see that again is a tangent to C1, as it turns out is a tangent to C2 as well. Now, in this case, because we know y must always be 1 on the line L, if we put in 1 for y onto M, we get x is equal to 1. So then the point M is the point here, 1, 1. Okay, so that's the point of intersection of the two lines. So now, you see, now we've done that far. This part then doesn't maybe seem like as much of a kind of ridiculous challenge as maybe it did at the start. Because what we're asking is to find the distance from P to M, okay, which is this distance, right? Find the distance then from M to Q, find the ratio of those distances and compare it to the radii. Okay, so when we find the distance, that just is the distance formula for P and for M. We get a distance of √5. When we go from M to Q, so again, M to Q, and get the distance formula, we get 3√5. So the ratio is √5 is to 3√5. Okay, so you could say 1√5 is to 3√5. So well, in this, you can see on the red line there. So this is √5 and this is 3√5. But we can see there that that would simplify down, dividing both sides by √5. We get 1 is to 3. And of course, we know the radii are in that ratio, because the radii of the first one was 1 and the radii of the radius of the second one was 3. So that was the final 10 marks. Now, some of you I know got bogged down in that in the exam. I'm certain of it. Hopefully with practice now that you can see that, okay, it's not outrageous, but it does take time, and it's a great one to practice, because a lot of those skills will show up somewhere in the Leaving Cert paper. Okay, so we're finished with the short questions that deal with coordinate geometry. Let's keep going.